All right, guys, so today we are multiplying rational expressions. And you may be thinking to yourself, why in the world would you start with multiplication? Why wouldn't you start with addition or subtraction? Well, if you remember back from adding and subtracting fractions, it's much easier to multiply fractions than it is to add or subtract. So we're actually going to start with multiplication, then move to division, and then go back and do addition and subtraction just because of the complexity level, okay? So we're talking about multiplying rational expressions. I want to just remind you again that it has the word ratio in it, which means that all these are going to be in fraction form. It also means that the rules or the laws about multiplying fractions apply here as well. So I want to use a real simple example just to start out here with, and then we'll move on to something else. So if I take 1/2, for example, times 4/5, there's actually two different schools of thought that you can do when you're doing this. Usually when we multiply fractions, we just go straight across, right? So I'm going to tell you that you can multiply and then simplify, or you can simplify then multiply, and I want to explain what that means. So this is the first method that many of you have already seen before. You just multiply the numerators and you multiply the denominators together, right? So I'm going to take 1 times 4, which is going to equal 4. And then I'm going to have 2 times 5, which is going to equal 10. And then again, we're looking for that GCF, right? So in this case, we're multiplying first. Now we're going to have to try to simplify. So GCF of 4 and 10, 2 will go into both of these numbers. So if I take 4 divided by 2, that's going to equal 2. And if I take 10 divided by 2, that is going to equal 5. So this would be my simplified fraction that I'd be done with. I want to show you one more way to think about this, okay? And as a matter of fact, I'm just going to move this straight across here if I can so that I don't mess up our workspace. So let's look at 1/2 times 4/5 again. I know we already know the answer now, but I want you to think about the fact that multiplication is commutative. I could rewrite this as 1 times 4 over 2 times 5. As a matter of fact, because it's commutative, I can move it around and I could say 4 times 1 over 2 times 5. I could even go as far as to, now this is really going to freak you out just a little bit, but I could really say that this is 4 over 2 times 1 over 5. I've not really changed that problem at all because of the commutative property. I could move these things around. Basically, all I did is I just changed out this 1 and this 4. But I want you to notice what happened here. What happened is now 4 divided by, I've got a greatest common factor I can see right away here. This really just becomes 2 divided by 2 is 1, and 4 divided by 2 is 2. And notice what happens here. I've got 2 times 1 is 2, and 5 times 1 is 5. Notice I didn't even get to that 4 over 10 answer. It took me right straight to the simplified version because I basically simplified first. Now, we could have really seen this right off the bat because all we had to do was just look diagonally right here, and you see that you have two numbers that will go into one another. And so again, 2 divided by 2 is 1, and 4 divided by 2 is 2. 1 times 2 is 2, and 1 times 5 is 5. There's your answer. So there's several different ways you could really go about this, and if you want to just learn to look diagonal, you can really simplify fractions very fast and not have to try to find GCFs and all this other thing. It's basically the same thing, it's just working a little bit different way. So I want to take a look at number 1 here because this is a perfect example of where this can really come into play. And so I want you to notice here, just look at your problem before you start, and I know our initial reaction is usually just to go for it and just multiply straight across, and you can do that, okay? There's no problem with that. But again, I want you to look right here diagonally. Look what you see. You see a pair of 7s, and you know if there's a 7 on top and a 7 on bottom, what happens to those numbers? Well, we know that they just go away. So notice how quickly now we get to 7v squared over 9v. And we know that our coefficients are simplified because these two numbers won't go into one another. So now the only thing we have left is we have 2 v's on top and we have 1 v on bottom. Remember we said from yesterday that we could also rewrite this as 7v times v over 9 times v, which means one set of these are going to go away. And it also means that I'm going to end up with 7v over 9, okay? So pretty simple, not really difficult at all, especially on these first few, for us to be able to work these things out. All right, this is going to get a little bit more complicated. So let's go ahead and let's move down to number 5. Again, we can do this. It's just a matter of we got to think about each piece that we have. Right now, it's really hard to see if I've got any common factors, so we need to actually do some work here. So first of all, I've got a 7. I know I can't really do anything with that. Now remember, I've got multiplication here, so I could go down here and I could work, or I could work over here. We'll just keep moving along the numerator. So now you notice I've got this mess, right? What could I do with that? Well, I could think about factors, right? I could think about the factors of 2, which are just 1 and 2. And I've got to use addition to get a positive 3. Well, actually, I'm just going to add those two numbers, right? So what I want you to see is you could rewrite this quadratic right here as x plus 2 and x plus 1. Now, initially, you may be thinking, well, that didn't really help me very much. But I want you to realize that we still have some factors here on the bottom, and possibly we could get something that might cancel out. So let's look at this particular quadratic I have right here, x squared minus 2x minus 3. Again, if I try to factor that out, let's just think about the factors of 3. The only factors of 3 is 1 and 3. I need to use subtraction to get a negative 2. So that would mean this would need to be a negative 3, and this would need to be a positive 1. And again, this is all back from chapter 4, okay? So again, it's really important. All of that stuff that we did, I said we're going to use it over and over and over again, and here we are. We're using it again right now. So again, now what I have is all of these factors are being multiplied against one another, right? So I'm just going to rewrite them again. It's x minus 3 times x plus 1 times x plus 2. And again, this is not really anything you can just put in the calculator. So this is why college algebra focuses on this so much, is because they want to make sure that you know what you're doing. So now we've got this whole big conglomerate right here. But remember, anything that I have a set of on top and on bottom as a numerator and a denominator, I can cancel those out. So notice what happens. Now I'm going to go ahead and cancel out my x plus 2 because I have a set of them. I'm going to go ahead and cancel out my x plus 1 because I have a set of those as well. And notice the only thing I have left is 7 over x minus 3. And just for good practice here, let's just think about what, well, actually, I don't want to do that right now. We'll do that here in a second. So this would be our answer, okay? This would be our most simplified answer because there's not any more common terms. There's no greatest common factors that we could pull out. So this would be our answer for number 5. So let's move to one of the more difficult ones. It's actually number 13. And notice here that it says we not only need to simplify each, but we need to state the excluded values, okay? So this is going to be quite a problem here. And actually what I want to do is, well, we'll work at a little bit of it here, and we may have to work down the page, okay? It is actually that long. Actually, you know what I'm going to do? I'm going to go ahead and copy this problem down here just so we have it. And we'll work it out down here at the bottom. Okay. So now let's just focus, and here's what I would encourage you to do. Just focus on one area at a time. So actually what we're going to do is I'm going to go ahead and just kind of make a mark around this. This is what we're working on right now. So just take it kind of one step at a time. And we notice that there is a 1 right here. So I'm going to go ahead and try to factor this. Let me go back to my black. The factors of 8 is 1 and 8, 2 and 4. And again, I got to use subtraction to get a negative 2. So subtraction to get a negative 2 would be 4 and 2, but the 4 would need to be negative, okay? So what I'm going to do right over here is I'm just going to go ahead and rewrite this as a binomial, n plus 2 and n minus 4, okay? So this really represents our little purple part of the problem that we started with. It just represents that. All I did is I just wrote it as a different way, okay? I wrote it as 2 binomials instead of the quadratic that we had here, okay? So let's go ahead and move across. Again, we've got a big old fraction here. And I want you to look at this right here, and I want you to just think about what you have, okay? We'll go to a different color here. Notice that I have a 9n right here. I have a 9n right here, and I have at least one 9n right here, okay? So because I have this in every single term, those will actually cancel out and will just leave me really with ones, okay? But notice here I have two n's, not just one n. So that means just think about what you're left over with. I'm left over with n minus 1 and really nothing on the bottom, okay? So really this whole big thing that I have here, the only thing I really have is I have an n minus 1, okay, right there. I don't have anything no longer on the bottom. So the only part I really have to work on now at this point is this one right here, okay? And I'm going to go ahead and tell you it's going to be a more challenging one, but we can do this. So let's go ahead and rewrite this. This is not in standard form right now, which kind of bothers me, and it should bother you. Notice that this negative is in front of this n squared. So really I have negative n squared minus n plus 2. Now again, something that really bothers me about this as soon as I see this is this negative right here. Okay, this negative right here kind of bothers me. And so I want to try to pull out that negative. So let's pull out a negative 1 out here to the front, and I'm going to rewrite this as n squared. Remember, what does it do when you pull out a negative? It just changes the signs. So instead of a negative n, it's going to be a positive n. Instead of a positive 2, it's going to be a negative 2. And now here I am again with something maybe that I could factor, okay? So I'm going to do this kind of quickly. Again, I'm going to make my two groups with n's. And think about the factors of 2, which is just 1 and 2. I've got to use subtraction to get a positive 1. So that means I'm going to have a negative 1 and a positive 2. So now what I want you to notice is this right here is basically my factored version of this, okay? So now what I'm going to do is I'm just going to put this down here at the bottom of my fraction, my rational expression that I'm working on. So I have negative 1 times n minus 1 times n plus 2. And again, what are we looking for? We're looking for groups that are on both top and bottom. So notice what happens here. I've got an n minus 1 here. I've got an n minus 1 there. I've got an n plus 2 here. I've got an n plus 2 there. So now I'm literally left with n minus 4 divided by negative 1. We should have a little bit of deja vu right now because this is just like one of the other ones we did last time. So I've really got negative 1 times n minus 4. If I distribute that negative through, I'm going to end up with negative n plus 4. Ladies and gentlemen, this would be my answer out of all that mess right there that I just started with on number 13 right here. Out of all of that, I ended up with just this one little answer. Now, what I want you to think about, okay, what I want you to think about is what my restrictions might be. And some of this I've actually got to go back to the original problem, okay? So if I look here, if any of this actually equals 0, I'm in trouble. Let's think about 9n equals 0. If n equals 0, then that's going to make this 0, okay? So first of all, n cannot equal 0. We know that for sure. Now here, I'm looking at this and I'm thinking, well, how in the world am I going to figure out what n can equal? Well, the good news is we already factored this, okay? Remember, we factored this right down here in this little green section, okay? We factored it already here. So I could set each one of these equal to 0, n minus 1 equals 0, and n plus 2 equals 0. If either one of those are 0, I'm in trouble. So again, add 1 to both sides. That means if n equals 1 or if n equals negative 2, either one of those is going to make me a problem. So they cannot equal those as well. So here are my restrictions, okay? Again, this is my answer right here. But n cannot equal 0, it cannot equal 1, and it cannot equal negative 2. If it equals any of those answers right there, and all of a sudden now I have a major issue, okay? So again, hopefully this has been helpful to you. I tried to tackle one of the bigger problems. That way you would at least have some help on some of the bigger problems. But if you need some help, obviously you're just going to be doing the even problems on this page. But if you have issues, please reach out to either me or Miss Wheeler. These notes will be on the page as well so that you have access to them. as you kind of go through this. So hopefully this has been helpful. Reach out to us if you need us. Thank you.